Okay, we're going to do some problems here on page 641, starting with number 9. It asks us to figure out the surface area of a sphere, and then they say the volume is 3,000 cubic meters. They don't give you a picture, but that's obviously a picture of a sphere. We need to figure out the surface area. Here is the formula for the surface area, 4 times pi times radius squared. Of course, what we need is the radius. They don't give us the radius, but they give us the volume. So what we're going to end up doing is working this problem backwards and figuring out what the radius is. And then once we know the radius, we can use that to figure out the surface area. So instead of V volume, I'm going to put 3,000 there. And I'm just going to work this backwards. Need to get rid of the 4/3, get rid of the pi, and get rid of that 3 above the radical 3. To get rid of the fraction 4 over 3, I'm going to multiply over 3 over 4. So it's like 3,000 times 3, then divided by 4, and that ends up being 2,250. This would just cancel that fraction out. This is pi to r third. Let's get rid of the pi symbol, divide by 3.14. This will turn into 716.2 is equal to r to the third. Now to get rid of that radical 3 there, you need to do the cube root of 716.2, and then on the other side the cube root and the 3 cancel each other out. Now you're going to need a calculator here. Most calculators, you're going to figure out the cube root, you're going to want to hit 3 first, then the second button, because you're going to go above things, and you are either going to hit this button here, which looks like a y and an x, or this exponent button, and then you are going to type in the number 716.2, and it should tell you what the cube root of 716.2 is. And I did this already. It's about 8.95. So be able to figure out how to work this into your calculator. Once you know the area, you can easily figure out the surface area. 4 times pi times, now the radius is 8.95. We'll square that. And the overall area is 1,005.9 meters squared. Okay, we're going to go to number 23 here from the book. I'm just going to read it real quick. Food, a sphere of frozen yogurt, was pressed into a cone as shown. If the yogurt melts into the cone, would the cone overflow? So basically, I kind of redrew the picture here, and the question really is this scoop of ice cream big enough for the cone? What has a bigger volume, not surface area, but volume? If the volume of the cone scoop of ice cream is bigger than the cone, then the thing is going to overflow. So this is a scoop of ice cream is a sphere, so we are going to use 4/3 pi r to the third, and we're going to compare it to the volume of a cone, which is 1/3 the base, which is a circle, pi r squared, times the height, which is 12. All the information is there, and so now we just plug it in. 4/3 pi, the radius is 4 cubed. If I go to a calculator, crunch all of this out, you will get 268.1. That's the volume of the scoop of ice cream. This is the cone now. The radius is 4. And the height we already know is 12. And this turns into 201.1, which is obviously this ice cream scoop is bigger than the cone, so it will spill over. It will overflow. I don't know exactly the words that they're using here. Okay. Okay, now we're going to hit some composite figures here on page 642. I've got 40, 41, and 42 all set up. They're slightly different just in a little way here, but they deal with a cylinder and a sphere. Sometimes you use a complete sphere, sometimes you use half a sphere. And they ask us to figure out the surface area and volume. I'm going to focus on surface area first. And if you look at number 40, you've got to realize that what is exposed to the surface, this is half a sphere. You have also a rectangle in the middle, and you have a circle that's exposed to the outside surface. Do not include this circle here on top or in the middle, because that's not really exposed to the surface. So really half a sphere a rectangle, and a circle. That would be the surface area. If you look at 41, you've got a half on the left, a half a sphere on the right, which makes a complete sphere. And then you have a rectangle in the middle. You'll notice there's no circles exposed to the outside because this yellow and this yellow are not really on the surface. So we're really just dealing with a complete sphere and the rectangle in the middle. And then when you look at 42, it's clear that you have the rectangle exposed to the outside. You have one circle on the bottom here. And you also have kind of a dip inside. This might be hard to see, but this top part is not a flat surface. It actually dips inwards. And this is half a sphere here. It's like a scoop of ice cream just got scooped out. Half a scoop got scooped out, but it's still part of the surface. Okay? So if we can just figure out what a sphere is, we can figure out half, what the circle area is, and the rectangle, because all of the numbers are the same. So the surface area of a sphere is 4 pi r squared. In this case, the radius is 2, so it's 4 pi 2 squared, which ends up being, excuse me, 50.26-ish. The surface area of the rectangle, and all three have that rectangle, it is base times height, but the base is the circumference. Circumference is 2 pi r. The height is 2.5. The radius we know is 2. When we plug all this in, we get 31.4. The surface area of one circle is simply pi r squared, pi 2 squared. This ends up being 12.56. Now, you got to realize for number 40 here, we only need half a sphere, so you're going to have to divide by 2 there. You need one rectangle, so you're going to include this, the half a sphere, and you got one circle on the bottom for number 40. When you get to 41 here, you need to consider I've got 41 here. I've got a rectangle, or excuse me, a half and a half, which make a complete sphere, so I don't need to divide it by 2. You can take the complete sphere. I also need a rectangle here, so you need this. And you don't have any circles that are exposed to the outside for 41 because you can see the yellow in here and here is not on the surface. So don't include the surface area of the circle. And then finally, when we get to number 42, you just got to consider what is on the outside. For 42, there's a rectangle. So we're going to need that surface area. There's the circle on the bottom, so we're going to need one of those. And we got half a sphere, so this is a whole sphere, so we better divide by 2 here. And we'll take half of it because it's half exposed to the outside. So do those calculations, add the parts that you need, depending if you're dealing with 40, 41, or 42. And then we'll go to volume. Okay, now I cleaned up the page a little bit, and now we're going to focus in on volume. You need to look at each one of these pictures and decide, what am I really looking at here? So for 40, you got a half a sphere on top. You got to figure out the volume of half a sphere on top here. And then in the middle here is a cylinder. So we'll figure out the volume of a cylinder. 41, you got a half on the left. You got a half of sphere on the right. So basically together you have a complete like ball there, or a basketball. And then in the middle you have a cylinder. Kind of running out of space. 42, you've got a cylinder. And you actually are losing half a sphere. So we got to minus out a half a sphere because it's like that cylinder, like a bowl of ice cream, got scooped out half of a scoop of ice cream there. Okay, so let's deal with the actual calculations. So the volume for a sphere is 4/3 pi r cubed. Of course, the radius is 2 on all of these guys. So when we put a 2 in there, 4/3 pi 2 cubed, this thing turns out to be 33.5. Now that's for the entire sphere. Sometimes we're not going to need the entire sphere. The volume of the cylinder, I should just put the word cylinder there and sphere here. The cylinder is base area times the height. The base of all of the cylinders is a circle, so it's pi r squared, and the height happens to be 2.5 on each one of those cylinders. And this calculation turns into 31.4. Okay, so those are the basic guys that we need. Let's look at 40. Which parts are we actually going to include? We need half a sphere, so we're going to need to take this 33.5 and divide by 2. And we also have a complete cylinder, so include those two, add them up. Okay, just add them up, whatever this result is. That is for 4D. Let's go to 41. Same kind of idea here. What are we looking at? We are looking at a half a sphere on the left, half a sphere on the right. So really we got a complete sphere. So we can just take this number and then we're going to add a cylinder, which is right in the middle. So you add the cylinder. Okay, and that would be space inside, which of course is volume. And then finally, when you get to 41, you are going to do something slightly different here. You have a cylinder, so you need this guy. And instead of adding, you're not going to add more to it. You're actually scooping out here. If you look at this picture carefully, you're scooping out, you're going to minus out half a cylinder. So first of all, you need half of this, so you're going to divide by 2 because you only want half. And you are not going to add it with the cylinder. You are going to subtract it, whatever that is, and that would be the surface area. Okay, hopefully that makes sense. Study the pictures. What are you actually looking at? What is, for the surface area, what is actually on the outside? For the volume, what is it made up of? The different type of components.